My family and I decided to build an autonomous shuttle in 100 days, and our first major goal is to get this golf cart fully operational using only an Xbox controller.
How dare you?
Hi, I'm Shane. This is day one of our journey, and today we're making a plan. As the saying goes, a plan is only as good as the day it is written. After making the plan, you have to continually make adjustments until you succeed. When you think about it, some of the best made plans were never executed simply because they were never even started. I like the Navy SEAL expression, prioritize and execute. So that's what we're going to try and do with our 100-day goal. Plan, prioritize, and execute. Our first step is to select a computer and an intermediate microcontroller to communicate between our sensors and stepper motors, then integrate a bywire interface with a test motor. A bywire system is simply a way of replacing physical actions, like turning a steering wheel or stepping on the brake, with an electromechanical system that can perform the same function.
Okay, so today I'm working on the bywire system for the cart. I have this Xbox controller that is used for like racing games. So I have the controller and the pedals, and I can connect these pedals and the steering wheel to the computer, and I can read their angle values and then their throttle and brake values. And I'm going to send those values over to our motors that we're using to drive our brakes, our throttle, and our steering on the actual shuttle. Right now I'm using this little motor to test it. So we'll be sending like the angle of the steering wheel over to the angle of this wheel. So that's what I'm working on today.
It's day 2, and Brandon has been working hard on the bywire interface.
I was able to get the readings from these controllers, and I was able to get them onto this computer. So you see here, I have the acceleration, the brake, and the wheel angle, and then here's the time. And they're all being read live feed from the actual sensors, so we can get the angles and the amount of throttle that's being used.
So with a completed draft of our 100-day plan and a successful test of our Xbox bywire controls, we're off to a good start. Day 3. We've selected an off-the-shelf PC for our high-level algorithms and an Arduino as our intermediate microcontroller. We've selected these because they're readily available and easy to use. We've also run some initial tests with a lidar. LiDAR is an acronym for Light Detection and Ranging. Essentially, the unit targets an object with a laser beam, then measures the amount of time it takes to receive the reflection back. The shorter the time, the closer the object, and vice versa. You get the idea. This LiDAR viewer has been set to use a 3-second refresh rate, so stationary objects will gain more definition over time. This LiDAR randomly scans the environment. It's different from most LiDARs, which have fixed scan patterns that leave empty bands in the scanned environment. You can see here in the background, we're actually seeing a 3-dimensional model of the house that's behind us here, and we can zoom around this and get some very accurate distances. But if you look in the background here, that's actually what we're pointing the ranging sensor at. Today, Brandon continues his testing of the bywire system.
Okay, so today was day 3. My goal was to get the steering wheel completely interfaced with the motors by the end of the day. But we ran into some problems. I'm having trouble communicating from the steering wheel to the other system, and I don't really know why. So hopefully I'll figure that out by tomorrow. We did actually make some progress. We got in some new motors. These are way more powerful. We were originally using this to test with, but this has got a lot more torque and a lot more precision. So we got that hooked up, and so we can start testing with the actual motors we're going to be using. So we made a little bit of progress today.
After a few days of testing and adjustment, it's day 6, and we're ready to mount a gearbox to the golf cart in order to press down the brake pedal. Austin is doing some welding to connect the arm to the gearbox so that it's ready for mounting. We've switched to a simpler Xbox controller rather than the original steering wheel design we were using.
That was so mean!
Alright, so it's the end of day 6, and we were able to get the makeshift lever to work, and we hooked up to the Xbox controller, and that's what we got done. Now we're able to apply the brakes.
Day 7 is here, and we're ready to set up the vehicle computer. Later, we'll run our first remote brake test. We also spent some time setting up the lidar but ran into some trouble. But more on that in a future video.
No, the bolt's a little bit smaller.
Oh, this is a 1/2 inch. Sorry, I gave you the wrong one. Okay, so basically what we did is we reattached the plastic from the golf cart just so that we have something to sit on. And then inside here, we're using lithium-ion batteries now. So we have way more room in the battery compartment, and we're actually hooking up all of our stepper controllers, and then we're running that all to the actual computer. We're gonna do a test here just to see if we got all the electronics hooked up.
Something moved.
Okay, so one of the motors is hooked up.
Yeah, so, oh,
Okay, so this is supposed to be the brake. One of the wires got swapped.
okay, we'll switch that.
This is wheel.
And is this brake
So
actually
the brake
sucked up?
is not working.
Okay, let's take a look.
Interesting.
A stepper motor is a brushless DC motor that divides its rotation into a number of steps and can hold its position assuming it's sized correctly for torque and speed. We're using a PC to command a rotation angle via C# programming language. That signal is being transmitted to the Arduino that uses C++ to convert angle into steps and speed. An off-the-shelf stepper motor controller converts the requested steps into the necessary motor controls to achieve the desired motor position. Okay, so we had to rewire a couple things when we transferred, so we're gonna just do a quick test and see if we got it working now.
Okay,
What?
so one of them is hooked up. Can you brake test? Yeah, brake works.
Brake, okay. Accelerator, not hooked up yet, but
Brake up, accelerator,
that one's that's wheel.
accelerator.
Wes, what do you have to say? Anything?
The most good thing is that this is working.
Try again. There you go, got one. And with that, we're ready for our first brake test. Okay, so we're gonna do a brake test. I'm gonna do a quick run and we're gonna try the Xbox controller. Okay, right backwards, keys on. Here we go. It works. We need to buckle the seat down. Well, our first brake test was a success, and we're feeling good about the progress we've made in our first week. Next up, we'll make some more configurations to our onboard computer, and we'll continue our initial testing of the bywire system. We hope you'll join our journey by subscribing. Thanks for watching.